Hello, everyone, and welcome back to another Stata pod class. Today, the final piece that we're trying to get through is some information on regression diagnostics. And in the book that we're using, that's chapter 7. And I'm joined again by my good friend and colleague, Michelle Delaney, and she is learning vast amounts about Stata, even though she knows a whole lot more about R. So anyway, that old man pirate joke. So at that point, we need to get you to get ready to look at a few of these diagnostics and kind of show you how the commands work. And then Michelle will take you through kind of how she found them in R, and we'll go from there. So first off, we're going to use the same data set we've used throughout this process. The old NLSW88. So yeah, here we go again. You've seen it and learned to love it. The next thing you have to do whenever you're running diagnostics in Stata, you have to run the regression first. You have to run the regression first because then it knows what it's doing diagnostics on. You can't just go in and hit the data set and then type in the commands for diagnostics without it knowing what regression result it's taking a look at. So don't forget, you have to run the regression first. One thing that is in your book, and Michelle was holding up the book a minute ago, and does it again. The one thing about the book is back there in table 7.1, okay? They do a nice little summary of the types of challenges that you can face. What diagnostic do you use and what's the remedy? Now, I was talking to Russ this morning about some of the same things and what he's using in his class. We're very consistent, and I'll try and point those out as we go through these things. But you could probably see the same table the way Russ is constructing his class. So be ready for that. All right, a couple of just informational pieces. In Stata, you can find a variety of help for different things. And so if you're interested in the diagnostics, and in this case, it's the particular tests, all you need is to use REG, DIAG. So that's the one part that'll give you a list. Now, they also put in, if you want to see the visuals or graphics for it, all you need to use is this help reg plots. This one's help reg diag, so for diagnostic. So anyway, those things are available to you as information and support inside of Stata. So at that point, one of the things I needed to show you as well was we're doing the command version. When I go through this, don't forget you can do everything in a pop-down point and click version as well. So I tried to put up the sequencing. Everybody is familiar with DF betas, it pops, but then there's a variety of other things you can work with. So I just wanted to make sure you were aware of that part. Okay, and so here comes the pieces, all right? Endogeneity, this is also known as a question of omitted variables. And Russ, I was talking to Russ this morning about it, and one of the things he highlights for you is the need to look at theory and other papers, and also just use your common sense. Now, there is one test that Stata does recommend. It's Ramsey reset, and that's pretty easy to do. They give you this null hypothesis, and as a result, if I come up with something significant, then I know that I'm looking at omitted variables. So the null is going to be there are no omitted variables. And so if I get something statistically significant, that disproves the null. So as a result, I'm going to have to look and investigate a little bit further. So that's one. He's getting to that later in your semester, so be prepared for that. The next thing we talk about is linearity and the parameters, and he will also use Ramsey's test for that. But in this case, you're trying to look at the plot between the residuals that you get and your predicted values. So, your variable of interest. And so in this case, you see how we've predicted the residual, and we've named it residuals. So this R1 tells Stata that this is the type of residual you needed to calculate. Down here is just a scatter plot that tells us residuals versus total work experience. So obviously you look at this and you say, okay, most of these are centered around 0. However, we probably got a little more up here than we got down here, and we certainly have a wider degree of variation. So we have some concerns here as we move forward. Now, one of the things that also is available to you is this kind of graphic that will allow you to go in and see the different setups you have for these different variables and combinations. So recognize that you have one spot where you can look at those things, and they treat it as a matrix. Now, my question ultimately is, does R have anything that's comparable?
It does.
But not as cool?
I don't know. I think it's just so R does have the capability to make a correlation matrix. You can either plain code it, or just like I was talking about in our last video about R, the Radiant tool within R, so you don't have to know how to code and know the text, and you'll just be able to kind of click the buttons in the different paths you kind of want to go to, just like Stata, is available, and that's how I did it for all of you. So if you open up that Radiant through your RStudio, so that is in the top part of RStudio, and then you click down the add-ins button and then click Start Radiant, and then it opens it in your browser. Once you load the data set, which is how I did this one, so I loaded the data set Professor West has been talking about, you have to then go to basics, tables, and then create a correlation matrix. And just like Professor West stated that in Stata, you have to run a linear regression prior to being able to see all the data. This is also how it's done in Radiant. So having and selecting the variables you want to see the correlation between is how you see the graph.
Perfect. And so one of the things you might notice is, again, in R, it's a classic correlation matrix. You got the variables right down the diagonal, and like most correlation matrices, you don't have a lot of other things above the diagonal. They can get everything accomplished down here, and in Stata, they just went ahead and eliminated the top of the diagonal or above the diagonal. Here, they're using it for a few extra pieces of information. So you can kind of get to the same thing either way, and that's kind of our point. When it comes to some of these basics, it's whatever you're most comfortable with. So that's kind of our approach. Next thing, multicollinearity, a great word to use whenever you're in a discussion in a bar. And so the common one, and Russ talks about this one, are variance inflation factors, the VIFs. And so this one's pretty straightforward. All you got to do is a command VIF in Stata, and you wind up with this information. Critical values, I always kind of forgot what they were, so I've tried to put them in one spot for you. So if the VIFs are greater than 10, you better check it out in terms of multicollinearity. We don't have anything greater than 10 in this data set. So at least on that one dimension, our diagnostics tell us, okay, we're not really in that much trouble. Now, my guess is that R can't do multicollinear. Oh, wait, go ahead.
So yes, R can also find multicollinearity, and you can see it in the bottom of that linear regression output, the variance inflation factors, and if their Professor S just highlighted it. So it gets the exact same numbers, and I just pasted them on the right a little larger for everyone to see. But yeah,
for people like me to be able to see. All right, got it. She's being kind. Go ahead.
But so it gets the exact same numbers as Stata does. and just with the click of a button. So, and it's a very, as Professor West said, it's a valuable thing to include when you're running regressions.
And more importantly, perhaps even than that, is they are critically important. But if people bring you regressions that they've run in Excel, they typically don't even think about the diagnostics and what assumptions they may or may not have violated. So if you send them back to evaluate their own models, that you can save yourself some time by not looking at trash. So in this case, or at least asking better questions. Yes. So regardless of the software you're using, there's information here that you can use to improve models all the time. Heteroskedasticity, another great word to use in social settings. And so the question about constant variance is what this one's about. They use, and Russ will talk about this as well. I mean, Stata will use more frequently the Brush-Pagan or the Cook-Weisberg test. And in this case, we have the same issue. Constant variance was the hypothesis here, or the null. And in this case, we've disproved the null. So we have some concerns about that in terms of whether or not we might have to do some sort of transformation. The other big test in here is White's test. And in Stata, the White test is just, I think the command is White test or WHT test. So you can get the same information either way. I didn't ask Michelle to do White's test in R, but I'm sure that it can do that as well. So don't forget those pieces. Remember, in both of these cases, you're looking at a hypothesis test to decide on the null. And so, so when you get through these things, one of the things you always do is get some sort of graphic of your dependent variable. And so we're going to run a histogram on wage and take a look at that way. And then you were able to do exactly the same thing over here in R. Did you use Radiant on this?
I did, but you can produce the exact same thing, just writing the line of code as well. So okay. Not too difficult either way.
Again, both softwares, there's some point and click capability to both, probably common, and then some you can write real quick lines of code. And when we say that, it's more like writing commands. It's not like you're writing extensive amounts of SQL code or something like that. So, and I think sometimes R sounds a little bit intimidating when people say, well, you got to code that. Well, yeah. Don't get too overwhelmed with the idea of having to code that because they make it pretty easy for you.
Exactly. I learned how to use Radiant in my statistics-based class last semester rather than my R-based class, which focused on writing a lot more code. So the Radiant tool was very important to know for the statistics side of things.
Yeah, and I think that I think that's a really important point, that R sounds a little scary because we hear people talk about it and we don't really know what it is, and there's a lot of kind of mystery around it sometimes. But don't forget, what they've done is through their Radiant tool, they've made it much more accessible. And so that's an important part of this kind of comparison we're trying to do. Now, once you do find that you've got some problems, the question is, what kind of transformation do you want to make in your variables? And so both of these softwares can do the same thing. They can give you suggestions. And so the command in Stata is the ladder command. It's built off of the actual ladder command, so it's a little something different. But they give you the distributions associated with different kinds of transformations. So the identity cell is what it actually looks like now. And if you log this, which is very common, we're going to get much more of a normal curve. So what you're asked to do here is, yeah, just go ahead and do a simple log function, and you're correcting correctly for this problem that we're dealing with. But they also give you a look at if you cubed it, squared it, all the different things that people tinker with to try and get their data to behave. I'm guessing, let me just look. Oh, I'll move on from here because that's just another look at the test. Wait a minute. Where was ours? Did R have that?
You can, yeah, you can run a log and different things. Sorry, I didn't know
Well,
you.
do you have this magic table?
Not as in depth as Stata, so I think Stata wins on that one.
I am a tingle. So anyway, I find this kind of helpful. I would bet probably somewhere in R somewhere you're going to be able to find it. But for me, just to be able to type in this and the variable name makes my life a little easier. But that just comes with familiarity. So don't. I'm not trying to throw any shade on R. Well, a little. All right. And then once we correct, we've done, okay, let's move on to influential observations. And Russ talks about DFIT. I talk about DF betas. And then we've got another one that's coming up, which is Cook's D. And so there's not a lot of special stuff here other than the fact that you got the command of DF beta, okay? The other thing that's happening here is I did a little sample reconciliation for you as well, because the observations in this data set started, you might recall, with 2,246. Then we had 370 that were missing values. So our final data set was 1876. And that's the number you use to calculate a critical value here. And so, and Russ will go into that some more because people debate what's the right critical value. And this usually is just kind of a, that's about where it is kind of thing. So what I tried to do here in the visual was say, as you would expect, most everything, all the observations are between the 0.4s. But you do obviously have a variety of outliers. Now, this also tells you in Stata specifically which observation you're looking at. And the reason that we got that was this. Because when I scattered it, I asked it to code the individual observations and label it with that variable. So anyway, that way you can get a better sense of what are some of these outlying observations, what leverage are they putting on your data set. And then finally, we've got Cook's D, another very common one. In this case, the critical value is 0.05, not quite as precise, shall we say, as the previous one, but I'm betting money we ought to go look at observation 856. That's just me. So anything that's out there that far, that would certainly, I'd certainly have to question that one. With that, I think we've gone through most of these diagnostics in your project. I'm only asking you to do what you see in the video. I don't need you to dig a lot deeper. So whether you're using eViews or R or Stata or SAS or SPSS, whatever your stats suite is, you can do these without a great deal of challenge. Michelle, how hard was it in R to go find some of these tests?
Not too hard at all, especially if you use Radiant. Once you navigate the different tabs that it offers, it isn't too hard to find.
How long do you think it took you to do the comparables here?
Just a couple minutes, maybe 10 minutes.
10 minutes? Okay, well, there you go. You can do these pretty quickly. I'm not going to tell you just how long it took me to do it in Stata, because it was way longer than 10 minutes. But I don't type quickly.
You did a lot more than I did.
Oh, okay. Well, that's, see, again, trying to be kind to me. So anyway, with that, I think we've done the regression diagnostics, summarized chapter 7 for you, allowed you to move forward with your project. And with that, Michelle and I will say goodbye for now. See you, Michelle.
Bye.